Question 1, 2021 Leaving Cert is a division of a complex number question. We're told that 4 minus 2i divided by 2 plus 4i is equal to 0. So the real part 0 plus ki. So we need to find this value of k. What number is in front of the imaginary part? So we're going to multiply top and bottom by the conjugate of the bottom. So 2 minus 4i. Top and bottom, 2 minus 4i. So multiplying the top, we're going to get 8 minus 16i minus 4i plus 8i squared, which is minus 8. And on the bottom, we're going to have 4 minus 16i squared, which is plus 16. So we're just going to get the 8's cancel on top. We're going to get minus 20i over 20, which is equal to minus 1i. So k is equal to minus 1. Nice easy part to start 2021. Second part of 2021, find the square root of minus 5 plus 12i. You could write minus 5 plus 12i to the power of a half and use the moivre. Part C in this question asks us to use the moivre. So I'm going to let the square root of minus 5 plus 12i, I think it works out better this time. You have to kind of round off with decimals in this, and the answer to this question is 2 plus 3i and minus 2 minus 3i. So in the rounding off here, you will get slightly off the exact answer. So just be careful. I think this is an easier way to do it. If we let this equal what they told us, the answer will be a plus bi. We can square both sides, and it works out nicely here. We're going to just get minus 5 plus 12i, and we can equate the real and imaginary parts. That's going to equal a squared plus 2abi. A by bi twice plus, now be careful here, it's plus b squared I squared. So plus b squared I squared is actually minus b squared. You could write plus b squared I squared and take an extra step. So equating the real parts, we have a squared minus b squared is equal to minus 5. That's not going to help. We also have 2abi is equal to 12i. So that will help. We can say that 2ab is 12, so AB is 6, so B is 6 over A, or A is 6 over B. I'm going to use this one because the 6 and the B look quite similar, and I don't want a 6 and a B down here to confuse myself. So 6 over A is B. So I have A squared minus 6 over A to be squared. I'll leave the minus 5 there just for now, equals minus 5. Multiplying this out, we're going to get a squared minus 36 over a squared equals minus 5. Now, this looks like we have to multiply by a squared to get rid of this a squared on the bottom here. So let's try that. We're going to get a to the power of 4 minus 36. And I'm going to bring the 5 across now. Minus 5 times a squared brought across as plus 5a squared. Now, you should identify that this can be factorized. A to the power of 4 plus 5a squared minus 36 is equal to 0. You could write it as a to the power of 2 to be squared, and you could say let x equal a to the power of 2. So I could do that. I could have, therefore I'm going to have x squared plus 5x minus 36 equals 0. You can see here it's going to be a 9 and a 4. It has to be 9 4s or 36, and we want plus 5x, so plus 9x minus 4x. So x is equal to 4 or minus 9. And if x is equal to 4, we will have 4 is equal to a squared. So a is equal to plus or minus 2. If minus 9 is equal to, we said that x is equal to a squared. So we got x to be minus 9. Minus 9 is equal to a squared. That's an a. And you can see that that doesn't work. We can't get a negative there if we square a. So if a is 2, take both of these. If a is equal to 2, we can say that b is equal to, ab is equal to 6. So if a is 2, b is 3. And if a is equal to minus 2, you could see b would have to be minus 3. And they want their answers in this form, a plus bi. So we have 2 plus 3i and minus 2 minus 3i. So part A took a minute. Part B took approximately 4 minutes. let's look at part C. Part C asks us to use the Moivre's theorem to find 3 roots of z cubed equals minus 8. Okay, well, let's sketch z cubed. Here it is, minus 8. So we can say here that z cubed is equal to minus 8 plus 0i. On this complex number, minus 8 plus 0i, the modulus, or is equal to 8, the distance from the origin to here. The angle from the positive sense of the x-axis all the way to here is 180 degrees. So my theta is equal to pi, or 180 degrees. So writing this complex number, minus 8 plus 0i is the same as 8 times the cos of pi plus I times the sine of pi. And the cos of pi is minus 1 and the sine of pi is 0, which you can see that's where we get the minus 8 plus 0i from. Now, that's z cubed. If we want z, we would have to get this to the power of a third, 8 to the power of a third. And I'm going to do it the short way, plus a third of pi. Now it's a pi plus 2m pi. And n is equal to 0 in here, so that's going to be 0. So plus a third after the sine plus I times the sine of a third times pi. So if we have a rotation of a third by 360 is 120, so each angle is going to go up by 120 degrees. So that's the way I like to do these. So in this case we're going to get 2 by the cos of pi over 3 plus I times the sine of pi over 3. I'll do these in the calculator in a minute. That's when n is equal to 0. When n is equal to 1, we said it's going to go up 120 degrees. Let's just check. With this guy, it's going to be a third of pi plus when n is 1, 2 pi. And a third of 3 pi is just pi, which is 180. Pi over 3 was 60. So pi is my next angle, and then my angle after that is going to be 180 plus 120, 300 degrees, which is 5/60 or 5 pi over 3s. So there are my 3 angles here. When n is equal to 1, it's going to be 2 by the cos of pi plus I by the sine of pi. And when n is equal to 3, it's going to be 2 by the cos, we said 5 pi over 3 plus I sine 5 pi over 3. Excuse me. If we type these into our calculator, for n equal to 0, you just type 2. You can use radians or degrees, whatever you choose. Sorry, when n is equal to 0, we're going to get 1 plus 3i, root 3i, 1 plus root 3i. When n is equal to 1, I'm going to get minus 2 plus 0i, and you can see that's the real solution there, minus 2 cubed. Minus 2 by minus 2 by minus 2 is equal to minus 8, so you can see that at the beginning. And when n is equal to 2, we are going to get 1, the conjugate of the first one, 1 minus root 3i. So a nice easy question to set you up for the 2021 Leaving Cert higher level paper, complex numbers.